Hi everyone, it's Mrs. Carter. Here's our last set of notes for this unit and for the year. Part of the unit is about neutralization. So by the end of this video, I hope you can do the following. Identify if a reaction is a neutralization reaction. Identify the correct products for a neutralization reaction. Identify the acid, the base, and the salt in a neutralization reaction. Explain the purpose of an acid-base indicator, and predict the color of litmus paper based on the pH being either acidic or basic. So let's go ahead and do a few notes. You should do these on your own paper. Okay, so we're going to think about how acids and bases react. So remember, if a solution with H+, basically an acid, is mixed with a solution that has an equal amount, should have made my line space a little bigger, equal amount of OH minus, or a base, we will end up getting a neutral solution. So we're talking here neutral being, a pH of 7. Now, it might be close if they're not equal amounts exactly. It might not be exactly 7, but, usually we end up getting somewhat close as long as we have kind of equal amounts there. So what we're looking at here is we are looking at having an acid here. And let me pick a new color. So we have an acid here. I can tell that this is an acid because that H is at the beginning. And it's going to react with a base, and I can tell this is a base because it has the OH at the end. And we want to think about what we get when that acid and base react. So we have to break this down into the ions that these are made of. So HCl is made of an H plus and a Cl minus. And our base, NaOH, is made of an Na plus and an OH minus. And so what's going to happen with this is that we are going to get those positive ions to switch places. So we're going to end up then with our H plus over here and with our Na plus over here. Our negative ions are going to stay in the same spots. So Cl will be there and OH will be over here, OH minus. So now we need to put together our two new products. And so what we end up with is we end up with NaCl. Since we have a +1 and a -1 ion, those are going to cancel out the charges. And then we end up with HOH, which we could also just write as H2O, or water. So we can see that when we get our products here for this, we are going to get, in this case, sodium chloride, salt, and water. But no matter what, when we do a neutralization reaction, we should always expect that we're going to have an acid plus a base, and that our products are going to be a salt of some sort plus water. You may notice that although this is a neutralization reaction, it looks very much like one of the old types of reactions that we've talked about before. So you may have noticed that this looks like a double replacement reaction, and that is exactly what it is. When we have those positive ions switching places like that, this is a double replacement reaction. So let's take a look at another example here. Let's just think about what we have in this reaction. So first of all, when I look at my reactants here, I notice that I have one reactant here that starts with H, and I have another reactant that ends with OH minus. Because this is starting with H, I know that this is an acid. Because this is ending with OH minus, we can categorize it as a base. If I then look at my products, I definitely have water here as one of my products, and the question is, what in the heck is this NH4Cl? So NH4Cl would be an ionic compound, and so we can generically call that and lump it into the category of salt. So when I have an acid plus a base making water and a salt, this is going to be considered a neutralization reaction. So this is the type of thing that I want to look for when trying to identify if a reaction is a neutralization or not. Let's take a look at another one here. Now you can notice that I have these coefficients in here. Do those coefficients really matter in terms of me identifying if something is a neutralization reaction or not? Well, they really don't. They just really need to be in there because we end up having some things that are not exactly a +1 or a -1 charge. So again, I have my H at the beginning here, so this is going to be an acid. I have my OH at the end, so this is a base. And this Na2SO4 would be considered my salt. And again, then I am going to get water. So again, this would be considered a neutralization reaction. Notice how I have labeled things here. That's the type of expectation that we have, is that you can identify which thing in the reaction would be an acid and which would be a base. Let's take a look at another one here. This time we're going to write out the products. So how do we know for sure that we're kind of getting the right products? So if we're going to think about the products that we're going to get, we certainly know that if this is a neutralization reaction, which in this case it would be because we have our OH here for our base in the beginning and our H in the beginning for our acid, that we should get water as one of our products. But now I have to think about, well, what's the other product? What's the salt going to be made out of? So again, I'm going to break this down into the two ions that are part of this. So I have a Ca+2 and an OH minus. I have an H plus and a Cl minus. And I'm going to think about the fact that those ions that are positive are switching places. So my H is going to team up with the OH minus, and that's really what I have that created that water. And then the other product is going to be formed by the calcium +2 ion combining with the chloride -1 ion. So think back to when we were writing formulas before. We're going to crisscross those charges, and I should end up with CaCl2 for this formula for the salt. So I'm looking for the other ions to be the things that go into forming the salt. So the last thing that we wanted to do today was talk a little bit about acid-base indicators. So acid-base indicators, what's the point of them? Well, it's that they can tell us if something's an acid or a base. And they do that by just changing color. And so you can see in the picture here that we've got a bunch of different things. We've got red litmus paper here going across the first row, and then we've got universal indicator and bromethymol blue, phenolphthalein, and then even red cabbage juice. So there are a lot of natural acid-base indicators, and they will change different colors depending on if they're in a substance that is acidic or basic or neutral. So the one that we want you to know is one that is, really, it doesn't have kind of shades in between. It's either, one color or another if it's an acid or a base. And so when we talk about litmus, which is, again, actually a natural indicator, we talk about red litmus paper versus blue litmus paper. And so we're going to really focus just on litmus paper that starts out red. And so litmus paper will always, with acids, turn red. So acid red is kind of a funny way of thinking about it. And so you can see here that our vinegar would actually be considered an acid. It doesn't really look like it's changed much with our tap water. So our tap water should be neutral. It's usually got a little bit of extra carbon dioxide dissolved in it, and so it's a slightly acidic. But then we can definitely tell here that with our lye or Drano that it's turned blue. And so bases always turn litmus blue. And so this is going to be a base. So again, acid-base indicators are going to tell us the pH, general pH range for a substance just by changing color. So in the end, hopefully we can do each of these. Can we identify if a reaction is a neutralization reaction? We should be looking for an acid plus a base makes water and a salt. We should be able to, again, look for those correct neutralization products for a reaction. We should identify the acid, base, and salt in a neutralization reaction. And we should be able to explain that purpose of an acid-base indicator, just a simple way to tell us the pH. If you have a pool, you probably do this in your pool. And then predict the color of litmus paper. And so again, litmus paper, acid, is going to be red. And if it's a base, it is going to be blue. Okay, let's do some practice.